Hi, I'm Jessica, and welcome to our second video on fractions. So in today's video, we're going to be taking a look at special types of fractions, and more specifically, we're going to be looking at mixed numbers and improper fractions. We're also going to be looking at how to solve a chain of operations with fractions. So to get us started, we're going to take a look at this improper fraction here, 23 over 20, and we're going to look at how to convert this into a mixed number. So the first thing we need to realize here is that our numerator is greater than our denominator. In other words, if we were to divide these two numbers, so 23 divided by 20, we would get a number greater than 1. In order to convert this into a mixed number, we're actually going to work on that division front here and put it into a little long division with 20 as our divisor. So here we go. 20 being the denominator becomes our divisor. 20 goes into 23 once, but of course it doesn't go in perfectly. So we're going to take 1, multiply it by 20 to give us 20. That sets us up with 23 minus 20 to give us a remainder of 3. So now we have all the elements we need to write our mixed number. We've just got to put it in the right order. This is what it's going to look like. We're going to take our whole, which is 1, the number of wholes that we've got. We've got 1 entire whole here. And then we put our remainder in the numerator position. And of course, in the denominator position, it's still our original denominator, which was the divisor in our division. So in our case, this leaves us with 1 and 3 over 20. All right, so now we're going to look at converting a mixed number into an improper fraction. And to do that, we're going to take this situation here. We've got 3 over 4, or 3/4, and we're multiplying it by the mixed number 2 and 1/5. Or 2 and 1 over 5. So the first thing we've got to recognize is that the 2 represents wholes. So there are 2 wholes. If I were to write this as a fraction, I would be writing it as a fraction of 2 over 1. And I want to do this because what I've got to actually do is take my wholes and add them to the 1/5. So that means that I've got essentially 2 over 1, and I'm adding 1 over 5 to that. And of course, we know that when we add fractions, we have to make sure that the denominators are the same. So I'm going to take my first fraction, that 2 over 1, and I'm going to multiply it by 5 in the numerator and 5 in the denominator as well. So that means 2 times 5 over 1 times 5. And I don't have to do it to the second fraction because it's already over 5. Okay, so the reason 5 is chosen is because it's the lowest common multiple between 1 and 5, and it's really handy because it's already the denominator of the second fraction, so it's a little less work to do. I have 1 less fraction to convert. The result in this case is, of course, only multiplying the numerator by the numerator and the denominator by the denominator gives us 10 over 5, which we are then adding our 1/5 to. And our final result here is 11 over 5. So we've gone from our mixed number to the improper fraction 11 over 5, which we can now use to do our multiplication back in the original problem. So our original problem now becomes 3 over 4, or 3/4, multiplied by 11 over 5. And once again, we just want to multiply the numerator by the numerator and the denominator by the denominator. And of course, because this is a multiplication, we don't have to worry about the fact that the denominators are not the same number, right? We just multiply them. So 3 times 11 gives us 33, and 4 times 5 gives us 20. So our end result here is 33 over 20. And we, of course, cannot reduce this, which you always want to check for, all right? And in this case, we can't reduce it. So it's going to stay 33 over 20 because it's the lowest we can get. Okay, so for our next example, we're going to be taking a look at how to divide a fraction by a whole number. So we have our fraction 4 over 17, and we're dividing it by the whole number 5. And the trick here is to really look at our whole number and convert it into its fractional form. So any whole number can be made into a fraction by throwing it over a 1. And so now we have the situation where we've got 4 over 17, and we're dividing it by the improper fraction 5 over 1. Makes it a little easier to do the division, because you'll see that we're going to have to take this division symbol and turn it into a multiplication sign, and then we're going to take that 5 over 1, and we're actually going to flip it. So we're going to be using the reciprocal of 5 over 1. This is how it looks. We've got 4 over 17, and we're multiplying it now by 1 over 5. So we've changed the division sign, and we've flipped our fraction to get the result of 4 over 17 multiplied by 1 over 5. And of course, now we've got a similar situation as our previous example in that we're multiplying two fractions. So we're just going to take the two numerators and we're going to multiply them together. And then we're going to take the two denominators and multiply them together as well. We don't have to worry about common bases or anything like that because it's simply a multiplication. So we just go ahead and do that. Numerator by numerator, denominator by denominator gives us the fraction 4/85. So before we declare victory here, we just got to double check and make sure that we haven't got any common multiples. So we're looking for the lowest common multiple between 4 and 85. And of course, they don't share any, so we're done. We cannot simplify this fraction any further. We leave it here. Okay, so now we're going to look at simplifying fractions when multiplying. But before we get into our example, I wanted to ask you this. Which method is best? Is it better to simplifying before multiplication or simplifying after multiplication? Well, actually, it really doesn't matter. We're going to be looking at two different strategies, same problem, but two different strategies. The key here is really just the multiplying part. This is only going to work, both of the strategies that we're going to go through only work when we're multiplying. So let's take a look. We have 15/14, and we're multiplying that by 7/10. So we've done this a couple of times before. We know that numerators get multiplied by numerators and denominators get multiplied by denominators, and we don't have to worry about common denominators when multiplying two fractions. So 15 times 7 gives us 105, and 14 times 10 gives us 140. So we're left with the fraction 105/140. And both of these are multiples of 5. So I'm going to reduce this simply by dividing the numerator by 5 and the denominator by 5. And we are left with 21/28, which is, of course, both, once again, these are multiples of 7. So I get to do the same thing again, only this time with 7. I'm going to divide 21 by 7, and I'm going to divide 28 by 7. And we get the fraction 3/4, which we cannot reduce any further. So we've simplified it as far as it goes. This is our answer. We're done. I said I'd use two strategies. So we're going to look at it again through a different lens over here. Same problem at the outstart. So we have 15/14, and that's being multiplied by 7/10. And you'll notice I've emphasized the 15, which is the numerator of the first fraction, and the 10, which is the denominator of the second fraction. And the reason I've done that is because both of those are multiples of 5. So if I take the 15 and I divide it by 5, and I take the 10 and I divide it by 5, I get left with the fraction 3/14 being multiplied by the fraction 7/2. And once again, if I take a look at the 14, which is the denominator of the first fraction, and the 7, which is the numerator of the second fraction, I notice that both of these are multiples of 7. So I'm going to take the 14 and I'm going to divide it by 7, and I'm going to take the 7 and divide it by 7 as well. My end result is 3/2 being multiplied by 1/2, which of course is 3 times 1 over 2 times 2 to give us 3/4. So you can see it doesn't really matter if we simplify before or after the multiplication. What matters is that we are only applying this strategy in a multiplication situation. So we're going to look at sign rules with fractions now. But first, I have a question for you. True or false? We can perform operations with fractions using negative numbers. The answer is true. So we're going to take a look at that by using this example here. We have -3/4 multiplied by 2. So we've used whole numbers and fractions before. So remember, just like when we were dividing, we're going to take that whole number 2 and we're going to put it into its fractional form, which means that we're going to be working with -3/4 and multiplying that by 2/1. Again, because we're multiplying, we don't have to worry about common denominators or anything like that. We just have to think about multiplying the numerators together and then multiplying the denominators together. But in this case, because of that negative, we're just going to review the sign rules quickly. If I have a positive and I'm multiplying it by another positive, the overall result will be positive. If I have a negative and I'm multiplying that by a negative, that also will result in a positive. If I have a positive and I multiply it by a negative, my overall result will be negative. And if I have a negative and I multiply it by a positive, it's also going to have a negative result. So just remember, if you have two signs that are the same, your result will be positive. And if you have opposite signs, you're going to have a negative result. So over here, we have negative 3 multiplying by 2, which will lead us to a negative result, or leave us with a negative result of negative 6. And 4 times 1, of course, gives us positive 4. So right now we have the fraction negative 6 over 4, and those are both multiples of 2. So I'm going to go right ahead and divide 6 by 2 and 4 by 2 to give me the reduced fraction of negative 3 over 2. Negative 3 over 2 being an improper fraction, of course. So I'm going to convert that into a mixed number, which leaves me with negative 1 wholes and 1 out of 2 parts. So in other words, I have negative 1 and 1/2. Now, notice how the negative just got pulled out and put in front of the whole. So we're left with the overall negative 1 and 1/2 as our answer. So next, we're going to talk about order of operations with fractions. But before we do, I have a question for you. True or false? The order of operations also applies to fractions in a chain of operations. The answer is true. We've just got to be careful of bad math, as in any other chain of operation problem. So let's take a look at our problem here. We have 3 over 4, and we're multiplying that by, in brackets, 2 over 7 minus 1/2, and then we're going to divide that by 10 minus 7 all over 8, and we're going to add 5. Bad math tells me I got to do my brackets first, so that's what I'm going to look at first. And you can see that going on here. So we still have our 3 over 4, but then in our brackets, we've got to look to changing those two denominators that are different, our 7 and our 2. We've got to make that a common denominator. And since the lowest common multiple for 7 and 2 is 14, that's what we're going to go for. So you can see the change happening here. 7 times 2 will give me 14, so I just have to remember to take my numerator 2 and multiply that by 2 as well. And then over here, 2 times 7 is also going to give me 14. So I just have to remember to take my numerator 1 and multiply that by 7 as well. My overall result becomes 4 over 14 minus 7 over 14. And now I have a common denominator, so I can actually do that subtraction. And I'm left with this situation right here. So 3 over 4 being multiplied by negative 3 over 14. And then I'm going to divide by 3 over 8 and add 5 over 1. Now, some of you might be wondering about where the heck that 3 over 8 and the 5 over 1 came from. So I just want to look at what was happening sort of simultaneously with the brackets. Okay? Because 10 minus 7 is all over 8, it has a common denominator. So it's almost like that 10 and that 7, that 10 minus 7 has been put in its own set of brackets. So I can actually do it at the same time as I did my first set of brackets. So 10 minus 7 gives me 3. So that's where the 3 over 8 came from. Now the 5, we've worked with whole numbers and fractions before. And it's always easier if we convert them into their fractional form. So that's what you see happening here. I had 5, and then I just turned it into 5 over 1 in its fractional form to continue the rest of my problem. So that's where we get our 3 over 8 and our 5 over 1 down here. So bad math tells me that when I have multiplication and division, or division and multiplication, I've got to go from left to right. So this is what's happening here. I had multiplication first. It was the furthest to the left. So I'm going to go with the multiplication first. So you see 3 being multiplied by my negative 3, and 4 being multiplied by 14. And that's going to give me negative 9 over 56, which is then going to multiply by 8 over 3. And some of you might be like, oh, wait a minute, that was a division. But remember, when we're dividing a fraction by another fraction, we've got to change the operation sign. So that negative becomes a multiplication. And we've got to take the second fraction and flip it. So in other words, we're going to multiply the first fraction by the reciprocal of the second fraction. So the reciprocal of 3 over 8 is 8 over 3. So our problem has now become minus 9 over 56 multiplied by 8 over 3. And we still haven't dealt with that addition of, by like the adding 5 over 1. We're not ready for that yet. So I ran out of space. So I'm going to come over here and continue my problem up here. Now you'll notice that my negative 9 over 56 multiplied by 8 over 3 reduced to negative 3 over 7 and being multiplied by 1 over 1. So remember, this is applying that second strategy in the multiplication problem that I showed you earlier, where you simply simplify before you go on. So in order to be able to do that, I had to take my 56 and divide it by 8 because it's a multiple of 8. And I divided 8 by 8 as well. 8 is, of course, a multiple of 8. And with the negative 9 and the 3, I simply divided both of those by 3. And that's what led to my negative 3 over 7 being multiplied by 1 over 1. And I still haven't dealt with that adding of 5 over 1 because we're not there yet in our order of operations. If I take negative 3 and I multiply that by 1, numerator by numerator, in other words, it gives me negative 3. And if I take my denominators, 7 multiplied by 1, multiply those together, I get 7. So now my overall result is negative 3 over 7, and I'm adding 5 over 1. I need a common denominator here because now I'm down to 2 fractions that I'm trying to add together. So 1 and 7, both are multiples of 7. So I get 2, or factors of 7, rather. That would be a better, stating it a little better. So what I'm going to do is actually take 1 and multiply it by 7, which means I also have to multiply the 5, the numerator, by 7 in order to make my denominators common. And that gives me the result of first fraction remains at negative 3 over 7. I didn't have to change anything about the first fraction. But now I'm adding 35 over 7 to that. Negative 3 plus 35 results in 32. And of course, my common denominator, I don't have to change it at all. So my final answer is 32 over 7. And I cannot reduce this number. There are no lowest common multiples to 32 or 7. So this is where I stay. We're done. So that concludes our video on operations with fractions. I really hope I've been able to convince you guys that dealing with fractions really isn't so bad and that you don't have to convert to a decimal. You can use a fraction as it is. In fact, oftentimes using the fraction is more precise than the decimal. So if you've been able to follow this and you understand it, then you're a fraction pro now. I would encourage you, however, to continue your knowledge and reinvest it, reinforce it by trying out some of our exercises. I'll see you next time.